Alright, we're doing problem 5 from chapter 1 of Rosenlicht's Introduction to Analysis. This is another set theory problem. So we're having I being some non-empty set. It's going to be an index set, and for every element I and I, we have that x sub I is going to be a set. Then we want to show, first, if we have another set B, if we take B intersection, the union of all these xi's is just the union of all the intersections. So how does this go? So first, for part A, so if we have some element x and it's in B intersect the union of I and I of x sub I, well, what does this mean? This is true if and only if x is an element of B and x is in the union of these x sub i's. This just means that there exists some I in I such that x is in x sub I. So there's some I in I where x is in x sub I. Well, let's just unravel definitions further. So if x is in B and there's some I in I where x is in x sub I, well then for that particular I, we have that x is in B intersect that x sub I. So this is true if and only if there exists some I in I where we have x is in B intersect x sub I. So if x is in B intersect this union, that means x is in B and there's some I for which x is in this x sub I. So that's true if and only if there's some I where x is in B intersect x sub I. And what we could do is we can just say, okay, so this implies that x is in this union here. But the entire idea, so this implies that x will be in the union of all i's of I of B intersect x sub I, namely because it's in one of them, because there exists an I where x is in here. So, but we can't necessarily go the other way. No, we can't go the other way, because if x is in this union, then there exists some I where x is in B intersects I, so you can go the other way. And so that's how you can do this first one, and you get that equality. So that's part A. And then part B has to do with complements, and namely the complement of the union is the intersection. So if x is in the complement of the union of all of these guys, what does that mean? So this means that so this is true if and only if for every I in I, x is not in x sub I. Because if there were such an I, then x would be in this union, but we know x is in the complement. So for every I in I, we have that x is not in x sub I. Okay. I'm trying to see if this should, so if x is in the complement of the entire union, that means that x is not in any one of these. So yes, this is a correct implication. So we want to get to this intersection, and so for every I in I, we have x is not in x sub I. So this just means that You want to show that it's in the complement, in the intersection of the complements. Therefore, so this is true if and only if for every I in I, x is in the complement of x sub I, and since this is true for every I, this is only true if x is in the intersection of the complements of the x sub i's. And that does this. So going backwards, if x is in the intersection of the complements, that means for every I, we have that x is in the complement of x sub I, and then that just means, taking what the complement means, that just means for every I, x is not in I, which means that x is in the complement of the unions. Alright, so that's how you do this. Thanks for watching.